Hi, welcome everyone. My name is Olia. I lead developer experience at Rootstock Labs. I'd like to welcome you to the Mastering Developer Tools series, which has been designed to show you how to elevate your developer experience on the Rootstock network. What is Rootstock? Rootstock is the longest running and first Bitcoin sidechain that is fully EVM compatible. What makes it a great place for developers to build on, a very special place, in fact, is that we offer a variety of integrations and very useful developer tools for your development across the full stack, actually. And today we'll be talking about data indexing, and we've got a wonderful guest here with us, Marcus from the Graph, who'll be telling us all about what the Graph is, how to use it, all the very useful features about it. Yeah, let's dive in. Marcus, would you like to introduce yourself?
Yeah, thanks so much, Olia. I am Marcus. I work developer relations for Edge and Node, which is one of the core developer teams working on building the Graph. And the Graph is a decentralized indexing protocol, and I'm excited to share how to combine Rootstock and the Graph to create some cool stuff today.
Oh, well, very welcome. It's great to have you here. Before we begin, why data indexing?
Blockchain is disorganized, terribly disorganized. I mean, it's whoever is able to make a transaction and store data into a block, regardless of which smart contract is recording that transaction, can do it in any block that is of course, at chain head. So every single block is horribly disorganized, and if we would like to have it be organized and therefore performant to use that data for data analytics or to have that data populate a front end in a timely way, you just can't use a block explorer to do that. You have to take the crazy amount of data that's being written to any chain since the chain's genesis until this very moment and put it into an organized database. And we do it with the graph in a decentralized way, where there's not just one major centralized database that you're relying for your front end on. We do it where we have over 100 indexers around the world creating and storing that data for you. So there's redundancy and no vendor lock-in. So it's pretty cool.
Amazing. Yeah, very clear. Thank you. That was very cool. So, what is the graph?
Yeah. So the graph is, I think, and this is how I like to say it. Like we all know what blockchain is. We're concerned about verifiability and state, but no one really was concerned about about how well we could read that data. It was all getting that data there and making sure there's consensus. Cool. We have that now. We have blockchain successfully, many, hundreds of thousands of blockchains now, including Rootstock out there that are very good at consensus and confident data storage. However, there really wasn't a way to think about how to pull that data and read it in a rapid way. And so there's lots of different ways to do that. And primarily, RPC calls was one way that is being done still today. Indexing through different means, of course, organizing that data and put it in databases. That's been done in Web 2 and now Web 3 for a long time. Like I said, we do it in a decentralized way. So there's many databases around the world permissionlessly being indexed by people who are incentivized by our token.
Amazing. Thanks so much. Also, super excited about today's session. Let's dive in and see what you have for us today.
Let's go for it. So I'll share my screen. Right. Sharing. And let me know if you can see this, correct? Yes, yes.
Yeah.
Yes. Okay. What I'm going to do is I'm just take the Riverside tab and actually bring it to my other screen. And then, okay, now we're good. I've got multi-screen. I can see you, Olia, and I can see this. So we're good to go.
Good. Let's
We'll just
go.
run, we'll just run through this quickly. I spoke to this a little bit. I just want to double down on understanding the graph from a high level to a medium level, and then we'll actually go in and look at the decentralized APIs that already exist in the graph that are already been indexed by the 100 plus indexers. And just understanding that you can interact with the graph without having to build a subgraph is a big part of it because there's open data just sitting there waiting for builders. And that's what we're going to get into right now. And then from there, we'll actually build our own custom rootstock subgraph API. That's kind of what you want to think. Think API, think subgraph. We're going to build a custom API that connects to a rootstock smart contract and see what events are coming from there. So yeah, let's go ahead. Querying Web3 data with the graph. And if anyone here just is a builder and they want to get right into code and just drag and drop code, this is a fantastic repo for this code. Essentially, one of the front-end developers on our team created a incredible repo with lots of different frameworks in it that anyone who's a front-end developer can just literally just drop it into their framework and say, hey, let's go plug and play with the graph. All you need is an API key, and that is able to be set up very quickly at thegraph.com. So, and then also you get 100,000 queries per month for free. And that's an awesome thing too. So go ahead and start querying the graph. With that being said, I like this quote. It's not the answer that enlightens, but the question. I think being curious is a big part of being a developer. And if curiosity is there, developers and anybody will find the tools to satisfy that curiosity. So the graph is one of the tools that can really satisfy curiosity, and asking good questions is a big part of having good amounts of curiosity. So let's get into understanding the tool that is the graph to solve some curiosity. So the graph, like I did say, is the blockchain is right optimized, and all different blockchains around the world, including Rootstock, are very much about getting that data there. And that's great. We have a absolutely production ready blockchain. We have production ready blockchains, and we've proven that we can do that in Web3. The problem is, like I said, there's a read issue. How do we have that be performant? And then also, how do we have that be redundant and decentralized and still have the same values that Web3 is proposing? Well, there is a 2.5 read solution, which is centralized indexing, which essentially, all right, well, we have a centralized indexer who is able to do the trick, and that does work. However, we are back to Web 2 kind of things where we have vendor lock-in, we have potentially a price raise that may be coming. If they change their tech stack, you're beholden to that. So we didn't really want to do that with the graph. We wanted to have decentralized indexing where we are providing the tools, the graph is providing the tools, and the core development teams are providing the tools for builders and indexers around the world to do this permissionlessly. And the goal is for all the core dev teams to move away eventually and for this protocol to be just operational as much as possible. So we're really trying to decentralize every part of our stack in the graph and eventually have this be passed on to Web3 as a whole. So that is essentially the graph. And a decentralized data layer of Web3 is here. And that's the summary of it. So 100 plus indexers worldwide. Anyone who wants to be an indexer, anyone out there who has experience with databases and DevOps, be curious about maybe becoming an indexer. You can get paid well if you're a good indexer. It's part of the deal of the graph. We want anyone out there who has the skills to be rewarded for that. And it's a global open data. So anyone out there who wants to access this data, once you have a API published to the graph network being all the indexers around the world, anyone out there who's a builder can access this organized blockchain data, which is pretty damn cool. So let's get into the next little bit. Any questions so far, Olia? Are we doing pretty good? Oh, you're muted right there. Can't hear you.
And it was all complimentary. Don't worry about it. Yeah, all makes sense. I just wanted, to compliment you on the graphics also. Very beautiful presentation you put there.
Thank you so much. Yeah, it's incredible what the founders and what my team is working on every day. I'm really happy to be working with these people. They're incredible, both on kind of like the aspirational vision part of it, and then also just the execution of the tech is really impressive. So yeah, subgraphs. I did say before, like APIs, think API, think subgraph, and that's pretty much what we're doing with subgraphs. It's just a very, I would say specific. Subgraphs are exactly this. They are customizable APIs. And we're going to go into building that a little bit later. And also we're going to take a look at already built ones in the ecosystem in just a second. And then also subgraphs are valuable. Indexers exist in the marketplace where we have all of these letter Gs here. These are all indexers around the world indexing data. And they exist in a competitive marketplace. They want to index data faster, better, cheaper. And they want to provide those services in a race to the bottom for you, the data consumer, for builders. And so that means the prices will be competitive, and you don't have to worry about prices, skyrocketing because, a centralized indexing company wants to do that. These are competitors. Also, subgraphs are competitors. There's another marketplace where the most valuable subgraphs have a certain amount of GRT attached to them, and the most valuable data pipelines include rewards. So that was very much by design. We want this, once again, to be a competitive marketplace where there cannot be value extraction. We wanted it to be something that could sustain for many, many years. And this is really the bread and butter of the graph. So let's go into customizable APIs and how we can assess them as valuable. For the visual learners out there, this is a live footage of Subgraph in action GIF, and I think it's quite cute. And essentially it takes disorganized blockchain data and puts it into databases that are housed by indexers around the world. Let's get a little bit more technical. The three main files of any subgraph are the manifest, which is subgraph.yaml, the logic, kind of what do we want to do with those events that are being emitted from chain. Do we want to do any transformations? Do we want to do any compute? We can do that within a subgraph, so you don't have to do that in your smart contract. We can save some money and do that in there. And then we can store it in the database itself, which is a PostgreSQL database, and we go ahead and have that stored in that database. And every one of the indexers potentially could have tens of thousands of subgraphs stored in their indexed in their software. And each one of those subgraphs has an API of which we can send our queries to as an endpoint. So that's essentially, these are the customizable instructions that are valuable. And this is actually the Graph Explorer just had a revamp. Let's go to the Graph Explorer now. It's very nice. Graph.com Explorer. It looks much better than that image now. And we can see all of the different subgraphs that are available, and each of these have endpoints. And each of these subgraphs are indexing 1, 2, maybe 100, maybe 1,000 different smart contracts and doing transformations on them and storing them in a database. And that database is replicated across many, many indexers. Let's go ahead and check out this one right here. This has, in one day, 7 million queries to this subgraph, and we can see more information about it. There's 48K GRT of signal on this subgraph, which tells indexers around the world to say, hey, you can get rewarded by this 48K. And then also people who stake into the subgraph can actually earn rewards. We can see here, there's not just one indexer behind this subgraph, but there are, let's see, it looks like 10 total indexers in this subgraph, which means you have redundancy. If anyone's power goes out as an indexer, you've got 9 others. Let's see, 14 indexers, which is pretty dang cool. And they're all competing. They're all competing for a query. If you send a query to the subgraph, well, you only need one response. You don't need 14 responses. So the one that is fastest and most performant wins, and they get paid for that. And so this is a cool thing. We're actually watching competition unfold right in front of us. And from the builder's perspective, well, if we want to actually query how they've organized this data as UNCX lockers, if anyone's not familiar with UNCX lockers, it's awesome product. You can go in, and this is open data. We can see all of the information stored in all 14 different databases around the world. And we can send some test queries. And if you don't know GraphQL, that's okay. You just literally click around. If it is plural, you're going to be asking for more than one entity in the database. So let's say we want 100 entities of locked pools. I don't know what locked pools is, but we're just going to query it. And what attributes do I want to look at on this? What fields, do I want on this? And we'll just go through and just send query out right there. I don't know if we're going to get a return back. This is not an elegant piece of querying, but essentially you could play around and get information from this query. Just kind of click around, have some fun. Let's see what lockers is. First 5, ID, number of locked pools. Let's just take away. And really just start having a little bit of fun, just saying, there we go, that's a more simple query. We're able to get data back right away. So this actually begs the question about query optimization. If you don't know anything about GraphQL, that's okay. GraphQL is a query language. The graph.com docs is a great place to say, I don't know anything about GraphQL. We can go ahead and, let's see, GraphQL best practices. Here it is. GraphQL API. So if you want to learn about GraphQL, we have a real quick start on understanding GraphQL as a language and writing optimized queries. Because if you write a bad query, essentially, the indexer has to go through crazy amounts of data, and it just takes longer because computers are computers. Everything can be optimized. So learn GraphQL really quickly here and have a good time with that. Now, any questions with this, Olia, about kind of understanding from a high level that these are all different API endpoints that you can go ahead and build, design some queries, and then once you have a sexy query that you like, all you got to do is send it to this endpoint with an API key that you can go ahead and set up. 100,000 queries are free, and React, Next.js, whatever you prefer. Does that make sense?
Yeah, no. Yeah, absolutely. I love how visual it is also that you basically, as you say, it's kind of think here a little bit.
Was I frozen
you
there?
Back? Marcus? Yeah.
I'm back.
Yeah.
I'm back. Hello.
Okay. No, I love the interactivity. I love the, again, if you don't have the reference in front of you and not familiar with the language, you can just try and, as I say, just click around and see what happens.
Yep. And I do want to go one layer deeper here because I'm sure builders here want to say, hey, what exactly are these fields here that I'm clicking on? and like what data am I getting back? What am I returning? And that's where I'm going to go next. I just wanted to have a high level overview of kind of this dashboard and tinkering around with queries. And from there, once you've designed a nice query, you just simply send that query to this endpoint with an API key that you can set up here. 100,000 queries per month for free. So this is all right there. Cool. Awesome. All right. So let's go a little bit deeper. You guys are probably wondering, well, this is just what am I sending to a query? How do I design this a little bit better? That's a great question. What you can do is go to the About page. And a lot of times, what you will see is a repo that the builders have put there. Now, UNCX lockers have not put a repo on there. I'm sure if I was to take the time and dive in and look for the repo and find the arrangement of their database, find the schema of their database, I totally could. However, I'm not going to do that because I don't want to waste too much time. I'm going to go to a subgraph that I've used many times before. Is actually one of the first subgraphs that I have ever interacted with. The first time I was introduced to subgraphs, I wanted to understand more about CryptoPunks and understand that. And so we're just going to go into an old subgraph that I was first introduced to like 4 years ago now, and just understand how this exact same thing that we were doing at UNCX can be done pretty much, hopefully, with any other subgraph. Because these subgraphs are open data, that means anyone could build, you, me, Olia, anyone in the world can build one of these subgraphs. We like, and it's best practice to actually put the GitHub of the subgraph that you've built in there. Some do it, some don't. You have to find that. If you don't have it, that's okay. Some people don't want to have their code be public about how they've done their subgraph. It's up to them. So this is the CryptoPunks subgraph built by Jerry Colo, who's now a friend of mine. That's a close-knit group in the world of the graph. And all you got to do to understand how this database is organized is go to the schema. So if you have the schema right there, and the subgraph developer is a kind developer, they'll put comments in. And so from there, if you send a query to any one of these entities in the database, let's say you have an entity that's the account, and you send it to punks owned. Let's say you send it to account, and you want accounts, all the different accounts out there, and all of the punks owned. Let's go ahead and build that query right now. We know this is all punks owned by the account. Bought, purchases by account, all punks. The developer is taking the time to explain how the data is being transformed behind the scenes, of which we will go into in just a minute here. But just look at the schema for just like, I want to send some queries to a subgraph. Look to see if there's comments. That's always good practice. And we encourage developers who are building subgraphs to make the comments very clear. Total earned, selling punks. If you send a query to total earned, like what exactly does that mean? Well, in plain English, you could have it a little bit more clear. And we encourage developers to go to the schema if you could find it, and then from there have a little bit more understanding. So to send a query to the subgraph of the account entity, all punks owned by account, let's go back to the Explorer. Oh, here it is right here. And we want to query the subgraph, and we want to say we want to get rid of the pre-populated GraphQL. All right, it's gone. And all we want is, what do we want? We want the accounts. And we also, it's good to have the ID. That's just good practice. We don't want bot. You see, I'm kind of just tinkering around here. I'm just poking. That's all I'm really doing here. I'm just poking it. And do I have accounts ID? And I have punks owned. Where is it down here? And let's see how it goes down. We don't want punks owned. We want just the ID of the accounts. That's great. And what did I say there? I think I said let's just do this. Accounts, and the first 5 accounts in the database, we will look at let's say the average amounts spent. So that's a calculation. The subgraph has done a compute in there, which is pretty cool. And then we want number of punks assigned, number of punks owned, number of purchases of the first 5 accounts in the database. And we also want to order it by, let's see if we could order it by, let's see, the total spent. That's a good one to order it by, because we can see, all right, who are the big dogs in here? And we'll order it by, let's see, order by total spent, order direction, descending. So the biggest number is going to be at the top, and we'll send that query out right there, and we'll see if we get some data back. There we go. So we're looking at the big dogs, the top 5 of all time in the history of CryptoPunks, of the average amount spent in there. Now, this is a big old number in there. Well, how is this computed? How is this gone? Well, now we have the chance to go to the schema and we could actually go into the subgraph itself and see how this was actually brought together. So it's kind of fun to kind of tinker around and try to get creative by going from here to the schema itself and be like, all right, what do I actually want to do? You could do a copy paste in ChatGPT and then have a good time coming up, hey, I want to come up with this query. How do I do that? And it can do a very good job with that as well. So is that making sense, Olia? Kind of how to tinker with an existing subgraph?
Yeah, absolutely. And now
Go
can't
have
wait
fun.
to actually get my hands on it. Exactly.
It's cool. Yeah, like you go look at Uniswap. Go look at like these big DeFi protocols. They all have a schema that is well defined. They all have comments. So ChatGPT can understand that. And you just literally copy paste the schema of Uniswap and look at the raw data and come up with some cool queries. Because you can go to, we can go to the subgraphs and look up, Uniswap. There it is, right there. So there's multiple Uniswaps. I think there's that one and there's that one. Anyways, you get the idea. Have fun. Go have fun. And from there, once you have your sending queries, 100,000 queries per month free, you can go ahead and build a cool dashboard or do some cool arbitrage or something like whatever you really want to do. It's kind of all right there for you. But now I want to transition into building on Rootstock. So, Olia, is there a smart contract out there that on Rootstock that you're like, this would be a cool one to tinker with? Because I've gone through the Rootstock Explorer. I found a few on the dashboard. I was wondering if there's any one that you could think of that you want to go to personally. I went to here and I was like, oh, here's some apps that we could take a look at.
That's a very good question. I don't know. Maybe we could just do something
Yeah.
simple with like, I don't know, with like one of the tokens. Yeah.
Yeah. I mean, this is an option right here. So I just went through here onto the apps and I said, let's take a look at this address and RAF US dollar. And what subgraphs do is they look at all of the events emitted from a subgraph, emitted from a smart contract from this block of which it starts indexing all the way up until right now. So let's take a look at the events here and not loading. That's okay. Let's go ahead and look at another. Oh, there it goes. Okay, did we get the events? No, we didn't. Events, come on up. Let's go back to the apps. Let's see. Let's look at this one. Blockchain wallet. No. Did I do Riff before? Let's do Riff. Let's do Riff on top here. This is kind of how you do it as a subgraph developer, as you're looking to index the data. You look at, oh, it's a proxy. This is a little bit more advanced. If a subgraph is indexing a proxy, I don't want to do that just because there's more techniques. I want this to be as simple as possible. If you're indexing a proxy, don't do that for your first subgraph. Just get the base smart contract if you can. Let's look for this one. Let's take a look at this. If this is not a proxy. Cool, it's not a proxy. 3 years ago, events. Let's see what events are coming out of this one. There we go. Okay, so we have some events coming from 2 years ago, from a year ago. This could be a week ago, this could be a minute ago, this could be whenever. But this is just for an example. Let's go ahead and dive in. We can take a look. A good bit of information to look at if you want is to understand where the first event was emitted. And that's a good place to start indexing because you don't want to index, let's just say from here at block 4 million. If you say start indexing a block 0, there's no information there. There's just nothing. So it's going to take a while for that subgraph to get up to that number. So for the sake of just efficiency in this demonstration, we're going to take a look at that and forget everything that's before this just for the sake of demoing. But it's good to know where the smart contract was deployed and then where to start indexing from. Now that you have that information, and you also have the smart contract address, which is right there, we have everything we really need to start indexing with indexing the smart contract. So let's go ahead and do that right now. We'll go to the graph.com studio. Actually, I'm going to back up from studio because this new landing page just launched last night. So I'm really going to show it off for the first time. It's a very nice landing page. I mean, look at this. This is nice. Like I'm clicking right now and it has all these little sparkles. That's very cool. So anyways, we're going to go to products and then Subgraph Studio. And Studio, you want to think of it as true studio where you could design and iterate and develop. Nothing here is decentralized yet. Nothing here is published to the graph network of indexers. It's all private right now. And we're going to call this Rootstock Smart Contracts Demo. Okay. So we have it here.
Marcus,
And this is the metadata that we would see.
Just a
Yeah,
quick question. Before we start working with the studio, how does one get into the studio? Do you need an account? Is it free? How does it work? Because
it's all
we
free.
just went from
All
London.
of this is
Yep,
free. Yep,
fantastic.
all of this is free. Go to thegraph.com, go to the products in the top, and then go to Subgraph Studio. And from there, you can start designing that custom API that you want to get that data and maybe transform it, do math with it, and then have an API at the end of it. So this is
Awesome.
all of the information that if you decide to make this subgraph public into the world and have it be decentralized, you will eventually click on publish. But when you're iterating and designing, it's all free. This is no cost here. When you publish, now you have to use GRT to incentivize the decentralized indexers around the world to get to work, because that's when tokenomics come to play. That's where rate limiting is taken away, because this is all rate limiting. It's all made for developing tiny little environment here. So just introducing Subgraph Studio. So what you'll want to do is, of course, install the Graph CLI. I've already installed it before, so I'm not going to do that right now just to save time. You could use, of course, npm or yarn, and then you'll initialize your subgraph. So I'll copy this here. I'll go to my terminal, and we're just going to spin up the code locally, and from there, we'll be able to go ahead and index our smart contract. So first, you want to decide, is the chain you're indexing EVM compatible or not? And we know Rootstock is. So we have a few non-EVM compatible things here. So we just say Ethereum. And then Subgraph Slug. This is automatically pre-populated by this copy paste on this dashboard, which I just like. I always like to go to this dashboard. It's very nice and easy to use. So I just do that. You could also not use the dashboard and do this without the studio if you're getting more advanced, but I always recommend people starting just use the dashboard. Directory locally, you'll create that in here, and then we'll find Rootstock. So there it is. So also, if you're a developer, there is testnet that is able to be indexed too, which is really nice. So, go ahead and use that to save some money and then deploy on main Rootstock. So we'll go Rootstock here. Now we need the contract address. So we'll go back to the address here. We got that. And here it is. Drop it right in. Okay. So it automatically gets the ABI, the start block, and the contract name. Some block explorers, I'll say this, and cheers to Rootstock to not rate limiting us. We send a query to get the ABI, the start block, and contract name to block explorers around the world. Some block explorers play nice with that query, some don't. And if they say, hey, it's failed, try again, keep on trying until it works. And if it doesn't work, you manually have to go into the block explorer to get the ABI, to get the start block, to get the contract name. We try to do our best to have that be a good developer experience, but if a block explorer doesn't work, it doesn't work. Yay, it worked. So, yeah. So start block was already populated. This is the start block of which the smart contract was deployed. Contract name. It's good to just have the name of the contract that is already in there. It's just best practice to have that, because if you want to index more, let's see, go to the code right there. If you want to index more smart contracts, each will have their own name in the subgraph, and it's good to have good naming conventions in the subgraph. Just name it whatever the smart contract name is. Don't change the name. If you have the name, keep it consistent. And this is the magic right here. So all of the events index the contract events as entities. Entities are database entities. So this is where the magic is. It's pulling all the events emitted from the smart contract and pushing them into the subgraph database with this little, at least it's scaffolding it to do that. It's not doing it right now, it's just scaffolding it out right now. And yeah. So add another contract. If you have, let's say, 3, 10, 1,000 Rootstock smart contracts, you could put them all here. If you're going to different chains, you have to use a different subgraph. So if you have multiple chains you want to get data from, you have to use multiple subgraphs. At this point, stay tuned for that to be different in the future. We're looking to have one subgraph to have multiple chains coming into. But right now, that's not the case. Do we want to add another contract? No. And next steps, you could run through this if you'd like. However, just to start building, I always like to go back to the dashboard. I think the dashboard makes it very clear of what to do next. So authenticate your local computer with this copy paste. I've already authenticated, so I'm not going to copy paste this into my screen because we're on a recording and I don't want to have to blur that out. So next, exactly. Next, you're going to CD into the subgraph. And so now we're in that folder, Rootstock Smart Contract Demo. And Graph CodeGen and Graph Build. This is typically what you'll do when you are doing some custom transformations and custom work with your events and saying, hey, this event was emitted here and here. I want that data in a different way, and I want to see if everything is going to fit together. That's CodeGen, that's type safety, and then this is the compiler. Before we do any of that, I want to go ahead and look at the code, and we'll just do this. And this is our local subgraph. And so I'll make this a little bigger. Cool. We have our subgraph.yaml, the 3 main files I said before. In the source folder, we have the mappings, which is the potential transformations that we want to do. Potential, I say intentionally. And then here we have the schema, and this is the database. So let's go over this. Yep, that's the database right there. So here is the manifest. This subgraph.yaml, you'll look at this as like the high-level overview of what the subgraph is doing. It's kind of like the Spark Notes, if you will, of what the subgraph is going to be doing. It's going to be looking at Rootstock. That's the network. That's the chain. This is the address we're looking at. The ABI that was brought in from Rootstock's wonderful block explorer, the start block. It's just giving us a high-level overview of what's happening. The mapping. Mapping, you want to think like a map. Where's the data going? Where is it going to be ending up? It's going to be ending up in these entities in our database. It doesn't say exactly how these entities are defined. It just simply gives them a name. That's all it's doing there. Just saying, this is the name of the entity. We're not getting into any more detail, just a name. And then we know it's all going to be ending here in the database. And then how is it going to be ending there? Well, it's going to be going, here's the event, and whatever comes from chain, we'll call this the accrue interest event, is emitted on chain. It triggers next this handler, and then eventually it'll go into somewhere in the database. And just because this is the initial spin up of the subgraph, it does one-to-one. There was no customization right now. You have the event, the accrue interest event. It triggers the handle accrue interest handler, where it could do some transformations if you want. And then guess where it ends up? In the accrue interest entity. There's no difference in naming right now because we're just doing boilerplate. Same with the approval event. If there's an approval event emitted from chain, it automatically triggers whatever mathematics or computation you want to do in here in the handler, and then guess where it ends up in? The approval entity. It's literally one-to-one. And it's just naming it. We're not going any deeper right now. This is high level. It says, hey, if there's a borrow event that's emitted, it will automatically trigger the handler to do some mathematics, and then it will go into the borrow database. Just literally, that's the way you want to look at this. It just goes one-to-one. That's all we're doing. So you're probably wondering, okay, well, if an approval event is emitted from chain, and the handle approval event is triggered, let's take a look at the handlers. And the handlers exist in that SRC folder. Remember I told you there's an SRC folder right there. And let's go into the approval. There it is right there. And also all the different handlers are right here. So once again, if we have an event, an approval event occurs, boom, all right, this data is passed into this handle approval function. This is the handler right here. And what it's basically doing, this boilerplate code that was spun up by the CLI, basically takes all the data from the event right here, and see all this 6 little pieces right here, and puts it into the entity. It literally does one-to-one. You have an owner piece of data that passes into the database of the name owner. You have the spender that comes from chain, and it goes right into the database, spender. You have the amount, goes to amount, and then this is some metadata that comes in from the chain. Every single event has some metadata, and we also store that too. We store the block number of which this event was emitted, the timestamp of which it was emitted, and the exact transaction hash that triggered this handler to be fired in the first place. So you get more data. And here we have an ID that is passed in, that is the ID for the entity that represents this event. And this is a concatenation of the transaction hash and the log index. So it's a big string of numbers. And it's converted into bytes. This little method right here converts it into bytes, which is much more performant. But essentially, it is a really good ID. I don't recommend for developers to change that ID if they don't have to, just because if you change the IDs to a string or to a number, it just slows everything down. Bytes are low level and performant, so keep those there. Any questions on how this happens? Yes, and eventually the database saves right in there. So it saves the entity. And any questions on that, Olia? Is that all making sense on how all that data is passed in for the database?
Yeah, absolutely. Very straightforward. I love the whole one-to-one, very easy to look up also.
Yep, and this is where we can get creative too. If we see a piece of data that is coming in through this approval event, and we want to say, hey, there's something in this borrow event that I want to bring into here and do some compute. Go for it. Like this is where you can start to say, I don't own the smart contract, and the way that the events were created, I don't particularly think that they were done well, or I can do some interesting mathematics, or I can start to align pieces of data from one thing to another, and like you can start to think creatively about this. And for a good example of what people do in these mappings, I like to go back to this CryptoPunk subgraph and just look at the SRC folder, the source folder, and look how much transformations this guy is doing. Like this guy is doing a lot of stuff, but essentially you'll see the same type of handlers in here. Every time a punk transfer event comes in, I mean, this person is doing a lot of things. And I'm not going to go into all the things that are happening, but this is where I want you to think of the history of any smart contract. If there's any event being emitted, what would you want to do? And how could that be more valuable? And how could you create a product around that? How could you say, hey, in the history of a smart contract, how could I do compute, do mathematics, take something in here, do good analyses that is automated through a subgraph, and then present that to a front end as a product? That essentially is what a subgraph can do. So yeah, I mean, there's a lot. This is just one file too. I mean, this guy went super deep into CryptoPunks. And these are all different styles of mappings that this person is doing. So very cool stuff.
Amazing, absolutely. Marcus, out of the top of your head, could you maybe share some of the products that came out of this sort of digging into a smart contract and what you can get from it?
Yeah, I mean, let's just go ahead and go back to the Explorer. I mean, this is live. All of this is running production software in Web3. So Lido, AirSwap, Snapshot, QuickSwap, UNCX lockers, Optimism. I mean, LivePeer. That's another. I love LivePeer. They're great, great people. Uniswap. There we go. Aave, Compound, Silo, ENS. CNS is getting used 2.2 million queries per day. This is all production. This is all live. Just scroll through and Block Square. These are big PageSwap. These are all big players in Web3. And there's a reason they're at the top of the Explorer. Like they're getting a lot of queries per day. And so if you want to think of the big boys of like, what they're using, this is how they use it. And it's just completely open data. And we're very proud to say this is all available for anyone to use the same data that they're also using. Premium, that's another big one. Spooky stuff. Yeah. So
sounds a very, very deep black hole there, or like when you start
what's that?
exploring. I said a very deep
Yeah.
black hole there when you start exploring. Just wanted to give some
Yeah.
inspirations for maybe the devs who watch
Yeah.
with what they could do. Yeah.
Yeah. I mean, all this data is available. I mean, if you want, you could combine QuickSwap and Lido and Snapshot and take all that data and all three different APIs and build something amazing. Like it's all sitting right here. And so we just got to get a little bit creative. So let's go back into the code and say, cool, we've got all this passing into the database and here's the schema. And it literally is just taking that data and here it's all organizing it. It just says the type of the data that's coming in right there and it stores it right there for the queries. And that's all it's doing. And so from, again, high level to the transformations, this is the mappings and how things transform. If you want to transform or not, no transformations are happening here because it's boilerplate. And then it's storing so that, the borrow comes right in here. And that's exactly how it does. So any questions on any of this before we deploy this thing?
No, let's go deploy.
Let's go deploy. All right, so we're in Studio, graph code gen, graph build. So let's say we've done some transformations. We want to see how it's doing. We could do graph code gen to see if everything is connecting well, because sometimes like we're taking from one file to another, we're taking the mappings and we're making sure that pushes correctly into the schema. It's good to always just run graph code gen to make sure these files are talking to each other. And it'll give you an error, and sometimes if it doesn't, it'll say, hey, correct that, please. Because we haven't done any changes, of course, it's going to work. And then graph build. And that compiles everything into bytes to make it ready for deployment. And then we deploy. So now we're connecting our local computer to the graph indexing, the 0.0.1. And then from there, it's uploading the byte code, deploying the graph node, and there it is. And so now we go back to our dashboard. Boom, already there. So it's already 57% done. It's not going to have all the data all the way up to chain head, but that's fine. Typically, it takes 2 to 5 minutes to have the database ready to send some queries. If I send a query right now, I won't get anything back. So give it a few minutes to get ready. It has no entities in the database. It was literally 2 seconds ago. I started indexing, so wait for that count to increase and wait for this progress to be at chain head if you want the most recent data. But once we see this number start to increase, and once we see the organization of the data, remember that image of all the different balls falling into different cups. That's essentially what's happening here. And sending queries, not getting anything back. That's normal. That's normal. Because we just did it 2 seconds ago. But it's looking for data that's 3-4 years old and putting it into buckets right now. We've done it. We built a subgraph on Rootstock today, deployed on Rootstock mainnet.
Amazing. Thanks so much for sharing.
Yeah. So once you have a query that you like, and once you have sent it from your front end to this endpoint, and once again, there's no API key required here because it's all centralized. This is rate limited, this is centralized, the testing environment, this API here is a testing one. Let's say you're at version 3.2.0 or 1.0, whatever, and you've built an extended subgraph with lots of features, and you want to get rid of rate limiting, and you want to go ahead and show your subgraph to the network and begin having it be public, you click on publish. And from there, we'll be able to actually go ahead and have more indexers on it. You'll have increased speeds, increased competition on it right there. So that's everything. We have entities 65 in there now. Starting to get some entities in here. Let's see if we get some data. There we go. Yay! We did it. We got data back. So, oh yeah, I think we've done a presentation under 1 hour. I think we did.
No, that's great. There was a lot of detail in there. So yeah, I'm very happy that tons to cover.
Cool. Do you have any questions? Is there anything else that you would like to see that could help Rootstock developers get going on indexing their data with the graph and subgraphs?
I think I have. So we've seen how intuitive it is, and kind of there's a lot probably that you can learn. We just go for it, and as we were tinkering, for example, at the beginning with like all the different options for querying, and then obviously there's a CLI that is very useful for the interaction. But like, are there maybe any sort of step-by-step guides for like beginners, proper beginners who maybe are not so savvy yet with kind of where even to start?
I mean, what level of beginner? Are we talking like smart contract beginner who have never deployed a smart contract, or beginner? Like, there's so many different ways to enter. So I guess my question to you is like, what type of beginner? And then I can answer that more accurately. Or subgraph developer beginner? Is that where more you're wanting to go to? Got it. Yeah. Okay. I would start at the docs, and I wrote these specifically for true beginners getting started. Subgraph best practices. And there's 4 right now. I just pushed. I didn't push it just yet. I have a PR that's about to come out very soon, but it has 5 and 6. So there's 6 best practices with subgraphs. And I think this is a really good place to just understand that you, as a subgraph developer, are writing code that is live. Like, it really affects performance. If you write good versus bad, this is indexing. So it's all about speed and performance. So it is good to really understand writing best practice level code makes the experience so much better. Writing good queries makes the experience so much better. And so, where is it? GraphQL. I think GraphQL also has its own. I did show the GraphQL. Optimize your queries with GraphQL. And if you think optimization from day one, you're going to be a better subgraph developer all the way through. So I would start with these. This is improving query speed with subgraph pruning. Essentially, pruning makes the database smaller. So the indexer doesn't have to have this massive database. And really, all you're using is just this much of the data. And that just slows everything down because the computer doesn't know, it doesn't have to search through that. So these are all these little techniques that are really about developer experience. And if you want to optimize your subgraph and then also learn the most important features of a subgraph, this would be the great part. So Derive From is a great technique to use as a baby subgraph developer that you'll use in every single subgraph moving forward. But it's not in the boilerplate CLI. It is just there, and I think it's one of the first techniques you should use.
Fantastic. Yeah, that's exactly what I was looking for. So I'm glad we showed that to developers. So hopefully that will be useful. Another question I had on the documentation, just generally, and perhaps anything else in terms of contributions. What are the ways for developers to contribute? Maybe code, do you accept pull requests, or maybe additional tutorials and educational materials, anything like that at all?
Yeah, we are in the process of revamping. I mean, we're always happy for a PR too. Like if someone has something in there in the docs that they see that could be improved, throw a PR out there. We're happy to take a look at it. However, if you're looking for more structure, I am in the process of working with a few of the team members about a revamp of our Graph Advocates program, where you can be able to participate in a way that earns rewards for your contributions within the Graph ecosystem. So we'll be more specific in time because, like I said, it's a revamp. But stay tuned if you'd like to stay involved and participate with technical knowledge and education. We want to reward that. And so there'll be more specifics coming out hopefully soon.
Awesome, yeah, exciting news. Do love a ambassador program. Right. I guess my last question would be around the community. I do believe Graph has a very strong developer community, and there's a lot of knowledge sharing. There's a lot of actually really fun conversations happening, a lot of ideas being pushed around on potential product ideas, as we've discussed. What is the best way to join the community? Where does one go?
Great question. If you want, just go to thegraph.com. And at the very bottom, of course, is the link of everything. That's where I go when I can't find the link to the Discord. Discord is quite busy, and I'll just drop this in chat for you. And I would recommend everyone go to the Graph Discord and just say hi, because that is really where you can get involved. I host a weekly show called Graph Builders Office Hours, which is featuring development-focused information and done in a sometimes interview, sometimes workshop format. It's very casual. We just try to have people that are building with our tooling come out and hang out. And then also, what I'd recommend is, of course, if you want to be involved with things. This is actually today. So we're having the founder of the Graph, Yaniv, come in and talk about the new GRC20 spec, which is a data standard that we're talking about. So we get this stuff all the time on Graph Devs. I'd recommend following Graph Devs, which is the development focused part of the Graph, where the Graph main account is very much, not just development stuff. This is where developers go. So
Awesome.
yeah,
Yeah.
those are the recommendations to stay involved.
Great. Yeah. Thanks so much. Thanks for sharing. And yeah, I think that will probably be it. Love the conversation. Thanks so much for joining us today, Marcus. It was an absolute pleasure. And definitely keep in touch and can't wait to see what the builders create on Rootstock
Yeah,
using the Graph.
absolutely. Absolutely. And if anyone has any questions, please follow me on Twitter, on X. Send me a DM. I'm happy to help from there.
Awesome. Fantastic. Thank you.
And this is me on Twitter right here, Marcus_Rein_.
That's
Take care, everyone.
Thanks. Cheers.